All right, so let's talk about imaginary numbers. You probably learned about them in school, right? Well, the story you likely heard about why they were invented, yeah, it's not the real story. Turns out their origin isn't about some simple equation. It's a wild tale from the Renaissance involving secrets, betrayal, and an incredible leap of faith.
So the big question is, where did these numbers actually come from? The answer most of us got in class is pretty straightforward, but you know what? It completely skips the drama, the mystery, and the real genius of their discovery.
We're usually told they were created to handle equations just like this one. X squared plus 1 equals 0. You know, an equation that seems to need a number that, when you square it, gives you -1. It's a nice, tidy explanation. But it's not what really happened.
Not even close. The truth is, for centuries, mathematicians were totally fine just saying an equation like that had no solution. End of story. No. The problem that really forced their hand was something way, way more confusing.
The real push actually came from something called cubic equations, the ones with an x cubed in them. Back in 16th century Italy, mathematicians ran headfirst into a paradox so bizarre it made them question everything they thought they knew about numbers.
And here it is. This is the equation that caused all the chaos. It looks harmless enough, right? At the time, finding a general formula to solve any cubic equation was like the holy grail of mathematics, and this one was a major roadblock.
So, what's so weird about it? Well, get this. You can plug in the number 4 and see for yourself that it works perfectly. 4 cubed is 64. 15 times 4 is 60. So 64 minus 60 minus 4, it equals 0. It works. The answer is a simple, very real number. But the formula to find that answer? Oh, that was a whole other story.
So, when the mathematicians used their new cutting-edge cubic formula, this is what it spat out. Just look at that. It was supposed to give them the answer 4, but instead it gave them this monster full of square roots of negative numbers, things that weren't supposed to exist.
And that was the absolute core of the paradox. The problem wasn't finding an imaginary answer to a weird question. The problem was taking an imaginary path to get to a perfectly real answer. How could logic itself lead you through this impossible landscape and still bring you out to the truth on the other side? It just didn't make any sense.
Now, to understand how they finally solved this, we have to meet the people involved. Because this wasn't just about math. Oh no, this was about fame, stolen secrets, and a nasty rivalry between two of Italy's greatest minds. The whole saga starts with a secret formula discovered by a guy named Del Ferro. After he died, another mathematician, Tartaglia, figured it out on his own. Then this other scholar, Girolamo Cardano, comes along and begs Tartaglia for the secret. He even swears a holy oath he'll never tell anyone. Tartaglia finally gives in, and what does Cardano do? He publishes it in his own book, kicking off one of the most famous feuds in math history.
And by all accounts, Cardano was, well, he was a real character. People who knew him said he was brilliant, for sure, but also treacherous and just consumed by jealousy. And it was this guy, this promise-breaking, ambitious man, who ended up publishing the very formula that unleashed this whole paradox on the world.
The person who finally looked this impossibility in the eye and figured it out was an Italian engineer named Raphael Bombelli. He decided to do something that was pretty radical for the time. He decided to take these fake numbers seriously. Bombelli's stroke of genius was to just stop calling them impossible. He basically said, okay, what if we just pretend the square root of -1 is a real number? Let's give it some rules, play with it, and see if the whole thing holds together. He was the very first person to really lay out the rules of the game for complex numbers.
So how did he crack the paradox? Well, Bombelli had a hunch that those two bizarre terms in the formula were connected. He made this brilliant assumption, did the math, and found that the cube root of 2 plus the square root of -121 was actually just 2 plus the square root of -1. And the same thing for the other part. Now look what happens when you add them up. The imaginary parts, the plus square root of -1 and the minus square root of -1, they cancel each other out completely. Poof, gone. And what are you left with? 2 plus 2, which is 4. The formula worked. It was like magic.
So Bombelli proved these numbers were useful, but they were still just weird, a mathematical ghost. It took another 200 years before they were given a form you could actually see and understand. And it was the great Leonhard Euler who gave the imaginary unit its famous name. He's the one who suggested using the letter I to stand for the square root of -1, and that simple, elegant notation has stuck ever since.
But the real aha moment, the thing that changed everything, was realizing these numbers had a geometry.
The complex plane gave them a home. It turned a number like a plus bi from an abstract concept into a physical point on a two-dimensional map. You could finally see them. Suddenly, the impossible was right there in front of you.
And this is what you can do when you can see the impossible. Euler discovered this equation, and many people call it the most beautiful equation in all of mathematics. I mean, just look at it. It links 5 of the most important numbers in math, e, I, pi, 1, and 0, in one elegant, mysterious relationship.
And this new geometry started revealing all these stunning, hidden patterns. For instance, if you solve the equation z to the 5th power equals 1, you don't just get one answer, you get 5 different complex numbers, and when you plot them, they form a perfect 5-sided polygon. It's this beautiful, hidden order that was there all along, just waiting to be seen.
Now, this isn't just a fun story about abstract math and pretty pictures. What started as what Cardano himself called a sophistic and useless fiction has become one of the most critical tools in all of modern science and engineering.
Here's a great little piece of trivia for you. In math class, we all learn I, but if you're an electrical engineer, you use J instead. Why? Well, because in their world, I already stands for electric current. The fact that they had to find a different letter just shows you how deeply these numbers are baked into real-world, practical work.
And their fingerprints are everywhere, seriously. Analyzing the electricity flowing through our walls, processing the signals for our phones and Wi-Fi, even the fundamental equations of quantum mechanics that describe reality itself, all of it relies on complex numbers. They are not optional. They are the language we use to describe our world.
The whole story really reaches its grand finale with the legendary Carl Friedrich Gauss. He proved something called the fundamental theorem of algebra. This quote is from his work, and it basically says that any of these polynomial equations will always have an answer if you allow for complex numbers. This was huge. It meant the search was over. There would be no more paradoxes. The system was finally complete.
And that kind of leaves us with a fascinating question to chew on. This whole story started with a confusing paradox, something that seemed like a mistake in the math, and it ended up becoming an essential tool for understanding the universe. It really makes you wonder, doesn't it? What other useless fictions, what other strange ideas from today's mathematicians are just waiting for their moment to completely change the world?